This presentation is all about the use of correlations in psychology. So a correlation is a statistical procedure. It's not actually a research method. It's a procedure that we use to identify relationships between variables. One important thing to note here is that correlations do not have independent variables, IVs, and dependent variables, DVs. They have covariables. And the reason for that is because a correlation cannot show cause. They just indicate that there's a relationship between two variables, so one thing varies in accordance with another. A further issue with correlations is what we call the third variable problem. For example, there's a relationship between the colour of grass and ice cream sales. The more yellow the grass gets, the more ice cream is sold. However, we all know that the actual causal variable here is temperature. The hotter it gets, the more yellow the grass gets, and the hotter it gets, the more ice cream we want to eat. So there are various types of correlations that we're going to look at. The main two are positive correlations and negative correlations, and then of course we can have a situation where there's no correlation. We're always looking at the gradient of the line on the graph. If it's at about a 45-degree angle, that means that we've got a really strong correlation. So let's have a look first at a positive correlation. A positive correlation means the variables change in the same direction, e.g. they both go up or they both go down. So in this example, the more hours you study, the better grade you get in your exams. The correlation coefficient measures the strength of the relationship. So for example, +1 is a perfect positive correlation, although you're never likely to get 1 as your correlation coefficient because there's always outliers or other variables. So you can see on this example, our correlation coefficient is plus 0.89, so that represents a very strong positive correlation. The plus in this example doesn't have a numerical value, it's simply telling us that it's a positive correlation. The other type of correlation we might get is a negative correlation. In this case, the variables change in the opposite direction, so as one goes up, the other goes down. So a good example here, the older your car, the more you spend in repair bills. So the correlation coefficient measures the strength, and again, -1 would be a perfect negative correlation, but you're unlikely ever to get a perfect one, as we said before. And again, the minus sign simply tells us it's a negative correlation. Of course, the other thing we might find when we're looking at correlations is that there's absolutely no relationship between two variables. There's no correlation. So if we look at the graph here, we can see that there's no pattern. There's not a line going up at a 45-degree angle or any really discernible line of best fit. The variables just seem to be a bit random. So in this case, there's no relationship between the size of your TV and how much you watch it. And the correlation coefficient for this would be very close to 0. So it might have a plus or a minus in front of it when you calculate it, but in fact that's pretty meaningless. It would be 0 or 0.1 or minus 0.1, for example. So let's now look at the strengths and the weaknesses of correlations. The major strength, of course, is that they measure the strength of a relationship. We can see how much of a relationship there is between two variables. And they're often the first step in research. If we can find a relationship between two variables, then it's then worth doing extra research to try and find cause and effect. The problem, of course, though, is a correlation can't show cause. It can only show relationship. And remember earlier we talked about that third variable problem. The other problem is they don't reflect curvilinear relationships, and we're going to look at that in more detail in a second. So a curvilinear relationship is an example here is the Yerkes-Dodson law. Any of you that do A-level PE will probably be familiar with this already. So it's the relationship between performance and arousal. If we think about it in terms of exam stress, that might be helpful. So we need a little bit of exam stress because it motivates us, it makes us work. If we didn't have any stress at all, we wouldn't bother working. However, that's only up to a point. If we get too stressed, it becomes counterproductive and it starts to have a negative effect on our performance. Now, obviously, correlations can't measure this because at first things go up and then they go down. So let's have a look at some questions now to see how you're doing with your understanding here. So, if teenagers have more Facebook friends than old people, does that prove they are more friendly? Well, we probably would find a positive correlation between Facebook friends and age because younger people tend to use Facebook more. But we all know that some of the people that we have as Facebook friends aren't actually friends in real life. We might have only met them once, we might never have met them. And actually, old people might have a circle of friends who they're very close to. The other issue with that sentence, of course, is the word prove. You never ever use the word prove in psychology. If you feel yourself tempted to use the word prove, strike it out and put evidence to suggest. Remember, the only thing that proves is bread. No theory in science is ever final. So please, 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 on behalf of examiners everywhere, do not use the word prove. Another question then, is the correlation between time spent on Facebook and the percentage marks in an exam likely to be positive or negative? So if we think about this, it's likely that it would be a negative correlation because the implication here, and it's the third variable, is if you're spending lots of time on Facebook, then you're not spending much time revising and studying. So we'd expect the more time someone was on Facebook, the less percentage marks they'd get in an exam. But obviously it's only a relationship, and the third variable is how much time is spent studying. Let's give you another question. If we found a strong positive correlation between high levels of aggression and the hormone testosterone, which would be the independent variable? I've been a bit mean there, that's a trick question. You'll remember that correlations don't have IVs and DVs, they only have covariables. So the answer to that question would be neither. Both high levels of aggression and levels of hormone are covariables. Here's another one to try. What is wrong with this sentence? Researchers found a correlation level of 0.64 between watching violent movies and committing crimes, proving once and for all that such films damage children. Well, the first bit of the sentence is fine. This is an example really of what could be a Daily Mail headline. But in scientific terms, it's just not right, is it? Again, proving. Correlations can't prove cause. They only can show that there's a relationship. And then, once and for all, that such films damage children. Well, there's no mention of children, is there? All it says is watching violent movies and committing crimes. Now, if you think about the correlation, it might be that violent criminals just like watching violent movies. It's a bit of a chicken or an egg. So we've got to be very careful with the conclusions we draw from correlational research. I've made another video on my YouTube channel that you might want to watch that shows you how to calculate correlation coefficients using Spearman's rank order correlation coefficient. However, it's important to be able to interpret the data. So this diagram should help you. You can see we've got 0 in the middle and then we go from weak to strong. So if we look at the first one, minus 0.78, that's obviously going to be a strong negative correlation. Plus 0.78 is going to be a strong positive correlation. 0.12 is probably close enough to be 0 to say it's no correlation. Minus 0.99 is a very strong negative correlation. Minus 0.02, again, the minus sign doesn't really mean anything. We'd say that this was 0, no correlation. Minus 0.4, we'd say that that was a weak negative correlation. Minus 0.6, we'd probably say that that was a moderate negative correlation. 0.5, again, a moderate positive correlation. And finally, 0.99 would be a strong positive correlation. One other thing you might be asked to do in the exam is to write a correlational hypothesis. Remember, correlations have covariables, not an IV and a DV, and you must use the word relationship or correlation, not difference, because you're not looking for a difference, you're looking for a relationships. So your alternate hypotheses, there will be a relationship, positive or negative correlation between blah and blah. If you just say there's a relationship, then it's a non-directional hypothesis. If you say it's going to be a positive or negative correlation, then it's a directional or one-tailed hypothesis. And our null hypotheses, there will be no relationship between blah and blah. Any relationship is due to chance. Now, just like when you're writing an experimental hypothesis, you must be really careful to operationalize your variables, which just means state them in a clearly measurable form. Okay, so that concludes our presentation on correlations. Make sure you read the appropriate section in your textbook just to reinforce your knowledge. Complete some past paper questions on correlations and watch the other videos on my YouTube channel. There's one on correlational activities and there's one about how to calculate Spearman's correlational coefficient. Thank you for listening.